360 kilometers above the Earth, man's new permanent outpost in space has taken shape. When completed, the International Space Station will be the largest ever structure in space. As big as a football pitch and weighing 400 tons, it will circle the Earth 16 times a day. Special windows give the astronauts a view of 85% of the Earth's surface. Permanent access to the unique environment of space is pushing back the frontiers of science and research. By eliminating the effects of gravity, scientists can build a better understanding of the physical forces on Earth, even the workings of the human brain. Man has long dreamed of building a permanent station in space, but for years space programs developed separately in competition with one another. The International Space Station was born of a realization that only international partnership could make the dream a reality. The ISS combines technical experience gained through the American Space Shuttle program, the Mir Space Station, and 20 years of European experience with Spacelab. Europe, Russia, Japan, the United States and Canada are working together to build the station. Assembly of the ISS began in November 1998. From the Russian Baikonur Cosmodrome, the Zaira cargo block was launched into orbit. Next, Unity, a US-built node, was launched and docked onto Zaira. And in July 2000, the Zvezda service module was successfully added. Zvezda provides living quarters and features a data management and control system developed by the European Space Agency ESA. The first European-built science experiments have now arrived on the space station and are gradually being made operational. In 2004 will see the launch of ESA's major contribution to the ISS, the Columbus Laboratory. Columbus will house equipment in movable and exchangeable racks, enabling up to 500 separate experiments per year. Through the European-built cupola, astronauts will be able to observe the Earth from space, as well as controlling the station's robotic arms for external experiment packages. The European-built Automated Transfer Vehicle, ATV, will bring payloads and supplies to the ISS. Expedition crews are now permanently manning the ISS. They stay between 3 and 5 months, and the first expedition crew was launched from Baikonur on the 31st of October 2000, after 4 years of training. Each expedition crew provides a living experiment in weightlessness. Already, scientists have used weightlessness to measure the effect of gravity on bones and other parts of human physiology, shedding light on the common complaint of osteoporosis and on problems with the balance system. The Expedition 1 crew, on a US shuttle mission, saw the US Destiny Lab ascending to the station. Shortly before, another shuttle had brought large solar arrays and batteries to augment solar power on the ISS and allow the scientific experiment program to begin. In April 2001, the Italian ESA astronaut Umberto Guidoni became the first European to visit the station as part of a mission to install Raffaello, an Italian-built logistics module. The first European woman, Claudie Aigneret, is ready for liftoff to the ISS in a Soyuz capsule on a joint French-organized mission in October 2001. And she'll be followed by more ESA astronauts at a rate of 1 or 2 a year. Long before the 40 or so assembly flights are completed, man's permanent outpost in space has already become a success story of international cooperation.